So today we would be solving Leetcode question number 1696, jump game 6. So what the question really means is that there is a frog that needs to relocate from index number 0 till last index. That is, it needs to position itself at the last index uh, in jumping between all these positions, and while jumping, the position at which he is currently at will get summed up. So we want that maximum sum value, and there is a constraint that the index at which he is, from that he can jump at max a distance of k. Like if he is at index 0, then he could jump from here till this index, that is 1 and 2. If he would have been here, then he would have jumped 1 and 2. In this range it can jump to any of the index possible. Like if it was here, then it could have jumped here also, or it could have jumped from here till here also. Okay, so we would be starting with the recursive code first. So, and we want that maximum value for that sum which is possible. Okay, to help the reach the frog from the starting index till the ending index, and that is it. So we know that we would be writing a recursive code first and then memoizing it. So I would say int answer, that would require at some point index I the value of k that will be given to us, and a vector int ampersand nums that is initially given to us. Okay, so I know that after the index ends, if I goes greater than equals to nums dot size, then I am for sure going to return a value 0, because after that nothing is possible. So at this moment I wrote the base case condition first because that was pretty easy. Okay, I would be taking some answer variable int min that would be compared so forth. Now iterating over my indices, which says for int j is equals to 1 up till j is less than equal to k j plus plus. What it really means, that what is the minimum number of length we could have jumped? 1. And what is that maximum number of length that we could have jumped? That is up till k. Okay, that is, so we are iterating over the length of jumps that is possible. Answer is equals to max of, sorry, answer, not, it should not be answer, it should, let us say answer or result, or result, and here also result, and result, max of numset I plus answer at I plus j, the jump which we have made, that is our new I. We jumped from I and we did a jump of amount of j, so our new position is I plus j. The k remains the same and the nums remains the same, and at the end we will return our res, and in our main function we will just call for our answer function, in which we will pass our starting index as 0, k as it is, and nums as it is, and I think this would result in an accepted value. This would be accepted, but this would again give us a TLE or a wrong answer, because if something goes beyond the boundaries, then it would not accept it. Okay, so this shows a TLE. So we would try memoizing our code. So let us now memoize our code. Let us make a vector int dp that would contain the size, and I would say int n is equals to nums dot size for now. That would contain elements up to their size and a value int min. That is it. I know that dp at n minus 1 would always be equals to nums of n minus 1. Okay, that is very sure. Now let us go on iterating over our values. So at this moment I say if dp at I is not equal to int min, then return dp at I as it is. That went well. And we would just be saying that dp at I is equals to this, and here also vector of int of ampersand dp. We would be calling it here also dp, and at that last we would be calling it here also. I think this is it. Okay, accepted. But this would show us a TLE or a wrong answer, because if the numeric values goes beyond boundaries, yeah, that showed us a wrong answer. Let us just tabulate this all. So if we try tabulating it, what we would really do is just create a bottom-up DP of the same solution that we are having right now. The things that would vary are somewhere here. We would be calling a bottom-up DP, so everything reverses. Everything reverses our for loop that would iterate from I is equals to 1 up till I is less than n and I plus plus. And then what we need to do is just copy paste this amount that we are having, and there would be some changes. I think just copy paste this all. For now let us not do it here. Let us keep updating, because we could have done the same thing there also, but it would be better if we just update our dp of I here only, this compare it with our dp of I here only, and we are iterating from int j is equals to 1 up till j is less than equal to k, and I minus j should always be greater than equal to 0, because we are iterating. Yeah, I minus j should always be greater than equal to 0. And what we would really do in our bottom up dp is compare that dp of I with this, and then add nums of j, nums of I, and then for our recursive function call, what we would really do is dp of I minus j, that goes as it is. And at that last, if everything reverses, then everything should reverse, and we would not be returning dp of 0, we would be returning dp of n minus 1, and I think this is pretty much it. I think this should be accepted. This should be accepted. Yeah, but I think this would also show us wrong answer or a TLE. It gave us a TLE. So what are the things that we can optimize? We know that in this loop we are always finding that maximum jump that our k can make to give us a maximum value at dp of I, at dp at I. What we are really doing is that, At this moment we are finding what is that maximum value we can get from jumping from j is equals to 1 till j is less than equal to k. And we are doing a range of jump from 1 up till k. So in this range, what is that maximum value or that maximum amount of sum I can get for my dp of I? We are finding that value here. So for this thing we are doing a search of O of n, supposingly. So this portion would have been taking this n times and this something n times n square. We can skip this n computation and make this a O of log n, O of log n, by using a priority queue. Okay, so what I would be doing is saying priority QUEUE of pairs that would contain integer comma integer. One would be the value and the other would be index of that value in our nums. Okay, and at the start the same thing which I did, dp at 0 is equal to nums at 0. So let us push pq dot push dp of 0 comma 0, the 0th index and the 0th index value at my dp index, at my dp array. We would not be requiring this thing for now, just erase it. We would be going as it is from I is equals to 1 up till I is equals to n. What we would be saying, I know that at the top of my priority queue there would always be the highest value. For the first value that would be highest. My priority queue, my normal priority queue stores the greatest value at its top. Okay, so I would say while there are elements in my priority queue and I minus pq dot top dot second is greater than k, till the things are not in my favor, keep on popping and as and when things come in my favor, just go out of that while loop, initialize top as pq dot top. Okay, and then initialize dp of the same thing that we did here, res is equals to max of res comma nums at I plus this dp at I is equals to max of dp of I comma nums at I plus dp at top dot second. Okay, so top would have been containing that maximum value and that maximum values index at which position it is. Okay, so I said that dp of I is equals to max of dp of I or nums of I plus dp at top dot second. Top dot second would have given me that index for which the value is maximum, in my dp in that range, and I would just add that value to my current value nums at I, and then pq dot push dp at I comma I. What we really did here is that we found out that maximum number from I is equals to something something. If my frog is at I, and if it could have made a jump of k in that range of k integers, what would be the maximum amount it could have obtained from jumping in that range k starting from I? And at the very last, we would just be returning dp of n minus 1. And I think this is it. Good to go. And I think this would be accepted because we did an O of n log n, O of n, this for loop, n log n, the down one. This took O of n and this took O of log n, the priority q1. So that is it, guys, and thank you very much for watching my video, and see you in the next. Please like the video if you enjoyed it. Do comment down your thoughts about this video, and let's meet in the next one. Bye.